to write the quadratic function shown in the graph in factored form. So you have to step number one here is to determine the x-intercepts.
Mhm.
So basically where it crosses the x-axis. And it's really hard to see, but there's one at, I guess, -2 and +2. Do you agree with that?
Yeah.
I guess. I don't know. I mean, those could be 4s. I really can't tell. I think they're 2s though.
It's all right. Like, as long as we're
Okay.
just doing problems with like the same stuff, that's
Yeah.
pretty like this. I'm
Yeah.
fine.
So your instructor has been kind enough here to give you the FF, the factored form, a x minus p, x minus q. And they tell you that a is 1. So you substitute, okay, a is 1. P is this -2.
Mhm.
And then q is 2. So let me try to make this slightly more clear. It's -2. So the only thing really left to do here is to write x plus 2, because you simplify the signs, x minus 2, and you leave off a.
All right.
And then you're done with that part.
Fx x plus 2. So basically, it's like you just gotta plug them in.
Yes, you put in the values of the zeros, the intercepts.
All right.
Is that okay?
Yeah, I think so. Just we'll see how it is, I guess, once we start doing them.
Yeah. So the next one here says write an equation of the graph in vertex form. So let me copy the graph down so we can see that here. So the vertex form is written here. I'll write it again a little cleaner. F of x equals a, x minus h squared plus k. All right, and they're giving you the vertex. Okay, so they tell, like, this is really hard to see, but the vertex is down here. It's at 0, -4. And h is the x coordinate of the vertex. K is the y coordinate of the vertex.
All right. H is y.
H is k. I'm sorry, h is x, k is y.
All right. H is x coordinate. K is y coordinate. All right, so then I would give, all right, yeah, 0, -4.
You start substituting values, and again, a is 1, so that's 1. X minus 0, because h is 0. K is -4.
X minus 0 squared minus 4.
Right. So now you're just simplifying here. X minus 0 is 0. So this becomes x squared. You don't need to write the 1 out in front, and then you put -4.
All right. So what they're...
This is it for this part.
Okay.
So in part 1, you substitute the intercepts into the equation. In part 2, you substitute the vertex into the equation.
Okay, wait, sorry. Could you say that one more time?
In the first part A, you substitute the intercepts into the equation. -2 and 2 into the equation.
And then using those, you are able to find the vertex.
No, that's a separate problem. Part 2, I'm trying to tell you, you're doing the same thing, just in different equations. That part 2, part B, you're putting the vertex into the vertex form.
All right, and then
I still don't think that's clear, just based on the way you're responding to me. And it's okay if it's not.
yeah, I think we might need to practice it a little bit.
Okay. All right. So is it okay if I just deviate from this slightly and have you do just a bunch of the same type?
Yeah.
Okay.
Like,
all right.
Eventually.
This is the same type. Okay. So here's a graph. Here's -2, and this is +3. And I want you to write f of x equals a, x minus p, x minus q. And a equals 1. So we're going to just do factored form first.
All right. Write that. Factored form. Okay. F(x) equals x minus p, x minus q. So then,
So this one on the left is p. This one on the right is q.
all right. So then it would be f(x) equals 1, x plus 2, x minus 3.
Perfect.
And then you'd have to go.
No, you're done. You're done. Done.
All right.
Nothing more to do. Like you don't need to write the a, but you can. Okay. So let's do another one here. I think I heard something there like maybe there's this like, oh, like what else am I supposed to do on this problem? And it's like nothing. So this is 1 and this is 7. You're going to write x minus p, x minus q. A is going to equal 1.
All right. So then you'd have 1 parentheses x minus 1 and x minus 7.
Perfect. Okay, let's do another one. Do you have this equation written down? The general form?
Yeah, I'll make it a actual like square at the top of my paper too.
Okay.
That is that a factored form or?
Yes.
Okay.
Okay, so here's another one for you to look at.
And it's x minus p and x minus q, correct?
Yes, p comes before q. That's maybe one way to remember it. The letters are not important though. It's the fact that you're getting the two intercepts into the equation.
Okay.
Okay, so try this one on your own, please.
Okay, I got fx equals a parentheses x plus 6 and parentheses again x plus 3.
Yeah, perfect. Okay, so we've done 3 examples of factored form. Do you feel like you understand factored form?
Yeah, I think so.
There's nothing more that there could be to these problems.
Yeah, I think I understand that.
Okay, so let's try. Now we're gonna do vertex form.
All right.
So that's y equals a x minus h squared plus k. Make sure you have this written down.
Vertex.
H comma k is your vertex.
K. Okay, H and K.
All right, so you got this down?
And K, yes.
All right, so let's say I give you a graph where the vertex is 3 comma minus 4. This is H and this is K, and A is going to equal 1 in all the examples we do.
Mm-hmm.
So you take these 2 values and you plug them in for H and for K, and then A is 1. So your f of x or your y is 1, x minus 3 squared plus negative 4.
X equals. All right. Plus 4. So then, I guess for solving it.
No, you're done. You're done.
Okay.
You here's what you could do. You could not write the 1 and you can write minus 4. Like we call this the pretty step.
Okay.
But it's exactly the same.
All right.
But do you understand that all you did is take 3 and negative 4 and plug them into this equation?
Yeah, I do.
Okay. Do you have this equation written down so don't rewrite it?
Yes, I do.
Okay, so let's try another one here. Let's say I give you a graph. I tell you that the vertex is -4, 2, and a equals 1. You give me f of x.
Okay. Yeah, I think I got it now.
Okay, so a is 1.
Yeah,
X.
1, and then
Oh.
x plus 4 squared plus 2.
Perfect. Okay, and if you want to do the pretty step, you
Let's get
make
rid of
this x plus 4 squared plus 2.
All
Okay,
right.
let's try another one here.
So for like these, is there like more you do?
No,
Like ever, like how does this apply to other problems? Because like I know this applies to other problems and I get his work, but it's like it's never like accessible for me to.
I'll try and clarify that. Let's do one more of these.
All right.
And then, 3 is one of those numbers where you do 3 in a row, you feel good about like, okay,
Yeah.
maybe I truly do understand this.
All right, I'm gonna try and not write this one down and see how I do. So
Okay.
A is still 1, correct?
A is always 1 in our problems.
All right, sounds
Subject to
good.
change on the exam, of course, if your instructor's difficult.
All right. I'll keep
I
that in
don't
mind.
know what to tell you. It's
All right, so then f of x equals 1 in parentheses, x plus 5 squared minus 4.
good. Okay, so let's go back to this graph,
Mhm.
which is terrible, but I'll make a better graph here. So let me do this. Let me actually just make this like a better graph over here to the right. All right, so this is -2, 0, and 2, 0. And this is 0, -4. So I want you to, over here on the left, we want to do factored form. Can you give me the factored form of this graph? A equals 1.
Okay. Okay.
What's your answer?
Equals 1 parentheses x plus 2 and x minus 2.
Okay, and if we do this pretty step, it becomes x plus 2, x minus 2.
Mhm.
Now let's do vertex form. So I'll stand by here. Can you give me this in vertex form?
All right. Oh, and you only use the vertex, which is at the bottom,
That's right.
or it could be at the top.
Good.
Right?
Good. That's a good connection to make. Yes.
Fx. No, that's just y. Vertex is y. Y equals ax minus h squared. Okay, and if you have 0, -4, y equals 1 x minus 0 squared. Okay.
What do you got here?
Y equals 1 parentheses x minus 0 squared minus 4.
Okay, and if we pretty it up, it becomes x squared minus 4.
All right.
Okay. All right. So now this is key. Part C in all of these problems is proving, not really proving, you're showing factored form equals vertex form.
All right. So
And to do that, you take this one on the left and you FOIL it.
So like x times x and x minus 2. All right, so then would you also do that to the one on the right? Or?
So the one on the right, this is not really in a great form. It's actually okay as is, but maybe we'll see in the next one now.
Oh, so then this becomes x just minus 4, which is the same. Maybe.
Which is the same. Yes, that's what you're doing in part A, B, and C.
And would those ever be called equivalent or no?
Yes.
Okay. So
you can say they're equivalent.
Okay.
Okay, so let's do another one here. I think we found a method here that works.
Right.
So let me do like we just did. Okay, so here's your graph. I'll do it kind of nice here. It's 2, 0, 4, 0, 3, -1. So over here on the left, I want you to write factored form, and you only use the zeros. Only use the zeros.
I'm just gonna need the 1 sec. I'm gonna rewrite the factor in the vertex form.
Sure.
Fx. F. Q. All right. 2040.
Yeah, so write this in factored form first, please.
All right. So then a is always 1, x minus 2, x minus 4. All right, so you get 1 parentheses x minus 2 and then x minus 4 in parentheses.
4.
Yeah. Did I say something other than 4?
You did, but don't worry, that's okay. Sometimes we it's more important what you wrote down. So the pretty step is that it looks like this. Now give me vertex form, please. And like you said, A is 1. I'll make a comment about that after we're all done in a moment here.
Sounds good. X. No, it's Y. Is it fine if you write fx for vertex or y, or is there like a preferred?
They're the same.
Okay.
If it says function though, you want to use fx.
Okay.
Your class is kind of emphasizing that. So try to stick with fx. I've been trying to do that.
No, that's fine. X minus 3. Okay, I think I got it.
Okay, go ahead.
Y equals 1 parentheses x minus 3 squared minus 1.
Perfect. And if we pretty it up, we just drop the 1.
X minus 3 squared minus 1.
Good. Now, in part C, we're going to prove that we're going to show these are the same. So on the left, you're going to FOIL.
All right. I'll start doing that.
So go ahead and FOIL that and tell me your final answer, please.
X squared minus 6x plus 8.
Perfect. Okay. Now, on the right hand side here, you have to be careful here. You have to do a rewrite. So your rewrite is x minus 3, x minus 3 minus 1. If you do anything else besides this, you will not get the right answer.
Okay, so when it's a negative, you still do both negative.
Well, no. Like when you have a square here, you have to write it out as a pair.
Okay.
Do not square and square. You will get the wrong answer every time.
X minus x minus 3 x squared minus 3x minus 3x. X squared minus 6x plus 9.
Okay. And then when you subtract 1, what do you
Right.
get?
Positive 8.
X squared minus 6x plus 8. Are these the same?
Yes, they are.
Yes, they are. How was that?
Easier than the first time I've done it.
Yes, yes. So if you give me like a minute, I can probably find one more example like this if you would
Yeah,
like.
of course. Let's do it.
All right, so I gotta do a quick graphing thing and see if I can come up with something. These don't work out great right off the there's one. Okay, so here's your new graph. I'll actually snip in the nice graph here with the right points. All right, so here you go. I want factored form on the left.
All right.
And then vertex form on the right. And again, a equals 1.
Okay. X or fx equals 1 parentheses x minus 3 parentheses x minus 5.
Okay, good. If we pretty that up, it's x minus 3, x minus 5. Okay, vertex form, whenever you have it, go ahead and let me know.
What would happen if instead of a being 1, if it was like a equals 2?
You would just put a 2 here in front.
Oh, okay, so you wouldn't like multiply it by 2 or something.
You would after you foiled.
Okay,
But
so that's not too difficult, really.
No, it's not. I mean, I do need to make a comment about that. That like a equals 1 is like the exception. It really doesn't happen like that, except in Algebra 1 class. Like it would be reasonable for the instructor to give you different a values, like -1, 2, -2, anything really. One half.
All right. Fx equals 1 parentheses x minus 4 squared minus 1.
Great. So
and
on the left,
it up, then it would be x minus 4 squared minus 1.
Yes. So on the left here, I'd like you to FOIL.
X minus 3, x minus 5. X. I got x squared minus 8x plus 15, and I'm gonna do the other end. You have to directly write what it is. So x minus 4, 2 times minus 1. And then that's x. And then that leaves me with x squared minus 8x plus 15, which is the same as the other, which therefore makes it equivalent.
Yes. Okay, great. You mentioned, yeah, I mean, like I was doing a bunch of these here. I mean, we have not done anything where it's flipped, where it's, really anything that's sort of interesting, in my opinion. Like here is one where I'll snip in the equation as well. So this one is a equals -2. And you can see the vertex is up here now. Still has nice intercepts, but this is your factored form.
Mhm.
And then your vertex form would be a is -2, x plus 1 squared because of that one, plus 18.
All right.
So I should
Now,
caution you. I should caution you that like a is not always 1, but maybe it is for your exam. Go ahead.
What, like, I've probably asked this before. Sorry, I got Invisalign. I kind of have a lisp now, but if you have like up there the -2 parentheses x -2 and x plus 4, would you ever go like -2x plus 4 and then have x plus 4 and then
No,
minus
it's better to FOIL that first and then multiply by -2.
okay.
Like you almost want to treat it like there's another parentheses there, bracket,
That
and
first.
FOIL and then multiply by -2. That's preferred. That's better. What you said works, but it's not the best.
Okay. I was just curious. I was just used to doing like fractions kind of like that.
So I heard in the beginning here, you said point slope, slope intercept,
Standard.
and then standard. Okay, so do you have the equations for these?
Like just the formulas.
Yes.
I do on flashcards.
Okay,
I
good.
don't have them memorized though.
Yeah, you definitely gonna want to have them down for our discussion here. Maybe have those set aside here.
Yeah, I have them right next to my notebook.
Okay, perfect. Okay, so when you go from point slope to slope intercept, you are solving for y.
Mhm.
Okay, so here's what we're gonna do. We're gonna do some problems here where I give you, you're gonna be given point slope form, and then you need to solve for y. Okay. So for example, let's say it's y minus 1 equals -2x plus 3. You are going to solve this for y. And there's a specific sequence here of things that you do. Like you want to first distribute this -2.
So equals
You were just,
2x minus 6.
yep. And then you add this 1 to both sides.
So then y equals -2x plus 7.
Plus 5, minus 5.
Oh, my bad.
Okay, so now this is very important here. This line right here that I'm boxing in, and this right here, these are equivalent. The one up here is in point slope form. The one down here is in slope intercept form.
Y equals mx plus b.
Yes. Okay, so let me give you another one here. Let's say I tell you that it's y plus 2, -3x minus 1.
You have to multiply the -3. So you'd have y plus 2 equals -3x plus 3. Then you have to get rid of the 2, so then it'll become y equals -3x plus 1.
Good. So this line and this line are equivalent. Is that okay so far?
Yes.
Okay. All right. So if I go back to kind of our starting point here, point slope, slope intercept, you can also move from standard form to slope intercept form by solving for y. So we'll do a couple of those here.
Wait, sorry. Could you say that like one more time?
You go from standard form to slope intercept form by solving for y also.
Oh, and then point also does. Okay. So it
Yes.
all becomes y equals mx plus b like those two.
Yeah, we're going to fill in this, but let's say I give you a 2x minus 4y plus 4y equals 8.
Mhm.
Okay, and I say solve for y.
So you could write out like the slope interceptor point slope in order to solve it.
We're going to just get y by itself. Get
Okay.
y by itself.
So then I guess,
So you subtract 2x from both sides.
does it matter if the 2x is before the 8?
It is preferred, and I recommend doing this to put it before the 8.
Sounds good.
Okay, so now this 4 is multiplying y.
Four
So
times.
you
right?
undo it with division. Now, this is where you gotta be very careful. You're dividing everything by 4. You're not just choosing one or the other, it's both.
Oh, and that's how you'd have darn, only if I knew that for today I would have gotten a problem, right? All right. So then I would give you negative 1/2 x plus 2.
Yes. Okay.
Okay.
So again, what I'm boxing in, these are equivalent.
They are the same.
One is in standard form, one is in slope-intercept form. So let's have you try another one here on your own.
Will it always be equivalent?
Yes.
Okay.
Okay, so try this one on your own, please.
Okay. This is a slope intercept, correct?
Yes, I want you to do the same thing we did in the last problem. Solve for y. Get y by itself. Solve for y. Get y by itself. Same thing.
Okay, cool. Y equals 1/2 x plus 2. So is it like very common to have the first one as a fraction? Or the x to be a fraction?
Yeah, kind of. I mean, I'm choosing problems that are nice. So now let me choose one that's not so nice.
Okay.
Minus 4x minus 7y equals 10. So give this one a try on your own, please. You can definitely do it, but it's, you know, I can jump in here.
Oh no, I can see how they can kind of get more like tricky.
Yes.
Okay. Y equals minus 4/7 and minus 1 1/3.
Yeah, so it's minus 4/7 x, and then minus 10 over 7.
Minus, okay, so I would not write it back into like what, like with a whole.
Let me know if you want me to show the work for this.
Okay, my only question with that one is like, so you would not write it out as negative 1 1/3.
No, definitely not. And there's sevens here. So no, you're beyond that, meaning
Okay.
like nobody expects you to do that anymore.
Okay, so I can just keep it like that.
Yes.
Awesome.
Okay, let's do one more, and then we'll move on to something else. Minus 2x. I'm sorry. Let's change that up. 2x minus 9y equals 15.
Okay.
Negative 15.
Okay. Is it y equals 2/9 plus 15 over 9?
Yes. So 15 over 9 actually reduces, but it's minus 9y equals minus
Oh, yeah,
2x
you're
minus 15.
5 and 3.
Yeah. So y equals 2/9 x plus 5/3.
So reduce when you can.
Absolutely.
Awesome.
Okay, so if we go back to our, I actually call this a flow chart. To go to from point slope to slope intercept, you solve for y. To go from standard to slope intercept, you solve for y. Now, this is another path that is possible, slope intercept to standard form. And you might be thinking, well, can we go from point slope to standard form? Yes, but it's like you would go to this one first.
Okay.
Like you would take this path and then you would do this. Now, the one that you rarely do is this one right here. This is rare. It's almost impossible to do for most students. It's very difficult. So we're not going to focus on that one, but we are going to focus on going from this to this. So let me pull up, make some problems here. So again, let's say y equals minus 2x plus 1. And we want to get it into this form over here on the right. So there are some rules. A, B, and C are integers. So it means no fractions, no decimals.
All right.
A has to be greater than 0, so it's positive, meaning the thing in front of x. And potentially a third one is that it needs to be in reduced form. I don't know how often this would happen to you, but it would be like if you had like 4x plus 8y equals 16, everything's divisible by 4, so you would want to reduce that. Okay, but in short here, the first thing here is like in terms of like what you do, you get x and y same side. So in your problem, what would you do to get x and y on the same side? Hopefully you would add 2x.
Yeah.
So you have 2x plus 1y equals 1. Now, are the numbers in front of the variables and over here on the right integers? Are a, b, and c integers? A is 2, b is 1, and c is 1. Are they integers?
Yes.
Yes. The second one here, there's no work in this problem, but it's 2x plus 1y equals 1. A is positive, so we're good. So again, these are equivalent.
All right.
So let's try another one here.
And that would always be equivalent, correct?
Yes, all the forms have to be equivalent. Y equals 4x plus 3.
Okay, so you have to subtract 4, so minus 4x plus y equals 3.
So this looks good, except this is negative. So to undo that, you multiply everything by a negative.
And then you'd have 4x minus y equals negative 3.
Yes.
And then the first number cannot be a negative.
That's right.
Okay.
So then if you get that, here's the kind of the final variation that you might see, because you were asking about this, is 1/2 x plus 6. Okay. So when you move this over, not only is it not an integer, it's negative as well. Negative 1/2 x plus y equals 6. So you multiply by a negative, but then you want to get rid of the fraction as well. So you multiply by -2. So that gives you x minus 2y equals -12.
All right.
So let me have you try one on your own here, please.
Okay, sounds good.
Y equals -1/3 x minus 2. And I want you to put that in standard form, please.
1/3 x plus y equals -2.
Say that again. Is that your final answer?
Yes.
Okay, so got to go through the rules, right? Are the numbers in front of x, y,
you cannot
integers?
have it be fractions. You have to multiply it by 3, giving you x plus 3y equals -6.
Sorry, I didn't catch all that, but are you ready so you move this over, you get -1/3 x, or sorry, +1/3
I got
x.
my final answer is x plus 3y equals -6.
Yes, that works.
So this is kind of easy.
I like the way you said that. It's not meant to be difficult. It's if you know the steps to take, it's like you go hiking. It's like if you're going from point A to point B and you
Mhm.
know what you're doing, you get there. Similarly, you get there and then
Yeah.
you get there. This one over here has rules, and this one you don't do very often.
All right. Also, would you mind like right when the lesson's over is sending the PDF of this so I can take some
Of
notes on?
course. Yeah. Are you getting that? Because I send it almost always within 10 to
Oh,
15, 15 minutes.
yeah, I think so.
Check your spam if you're not, I guess.
All right, I'll make sure to do that. Um, okay. So for factored form and vertex, those kind of work together, and also these kind of work together.
Yes, they do.
All right, man. I really hope my test is gonna be like this because I feel kind of prepared for it.
Well, did you have it part of it today?
Yeah, I did, and
Was it like the stuff you've been doing in review?
it was stuff that I did in Unit 1 like quite a while back, so it's like I knew how to do everything, but it's just because I didn't do it for so long, I was kind of like foggy on it, and I also
Mhm.
didn't know my test was today. I thought it was in 2 days,
Ooh,
but my teacher just had it early, so it's just wasn't prepared, no stressing me out, so I had this get scheduled tonight. So hopefully tonight this will really help my grade out tomorrow.
I think it absolutely will. So got your test tomorrow. Anything else you would like to cover or talk about?
Um, Here, I have something that was kind of like on my test day that I found in my classroom. It was like write the equation of any line that. So it says parallel x equals 4. So then like make your equation and then like perpendicular to x equals 4. Or do you want me just to email you the picture of that so it makes more sense?
We've got it here. We've done this before. So
Okay.
this is the line x equals 4.
Mhm.
Okay. So parallel means it goes
Up and down.
up and down in this case. Okay. Because this is already vertical. So
Mhm.
any line x equals number will be parallel.
Will be parallel.
So for example, x equals 1.
Mhm.
Let me change the color here. Is this parallel? Are these parallel?
Yes.
They are.
Will it like
How about x equals -2? Let's just do one more here. These
okay.
parallel.
So for this, would you like does it matter what number you use?
No,
Like
no. And I think that was one of the problems is for students is like when there's so many options, it's hard for you to constrain yourself to be like, what should I choose? There's infinite options. Yes, there's infinite
yeah.
options. Okay, let's do the perpendicular now. So I'm going to redraw it. Perpendicular to x equals 4. So perpendicular means it meets at 90-degree angles, meets at 90 degrees. So it's going to be any equation, I'm sorry, any equation in the form y equals number. So let's say it's y equals 1. There's y equals 1.
Mhm.
Do those meet at 90 degrees?
Yes,
Yes.
you do.
Yes. How about y equals, let me switch colors here. Y equals -3.
They will
Did
meet at 90 degrees.
that they do. So it's
It'll
any,
always meet it at 90 degrees.
right, right. And these work in reverse. So if they give you a horizontal line, the vertical line is perpendicular.
Mhm. Okay. So then, shoot. Okay.
It's always just one test. It's feels like a big deal, but when you put it in perspective, a week from now, a month from now, it won't seem like as big a deal. You got a chance tomorrow to do better.
Yeah.
Um, and your parents will care that you can understand this, a week from now, 2 weeks from now. Sometimes in the moment seems more important than it really is.
Yeah. All right. Thank you for that.
Absolutely. So I think that does it for today. I really appreciate you scheduling, and
Yeah, of course.
I'll send you
Thank
the
you
notes
for
here
having me.
shortly. Have a great night.
You too. See you later, Matthew.
Okay, bye now.